Optical isomerism. Optical isomerism is the existence of two or more compounds with the same molecular formula but with different configuration. They have the same molecular formula but with different configuration. Don't forget that this is just, I just want to highlight the point because this optical isomers, it is very vast. When we were talking about the rotatory, talking about enantiomers and the destromers, but this is just, this first one is just an insight, an introduction, so that when we will now dive into the main thing, you will not find it very difficult. The two or more compounds, when they have the same molecular formula but with different configuration. Don't forget that we have L-glucose and we have D-glucose. It is because of the way they rotate plain polarized light. Those ones are explained in optical isomerism. So don't forget that for any compound to be optically active, it must rotate plain polarized light. Polarized light, it must rotate a plain polarized light. That is, if a compound must be optically active, it will have the capacity to rotate polarized light. Also, that compound which is optically active must have a carbon atom surrounded by four different groups. All these are the points. That compound must have a carbon atom which are surrounded by four different groups. Don't forget that the valency of carbon is tetravalent, which means it has the ability to bond with four different groups, even though it can bond with the same group, but it has that capacity to bond with, it has tetravalent. Tetravalency means carbon. Just like carbon can have this kind of bond. Do you get it? It can bond with something here, bond with something here, bond with something here, and something here. That is why the valency of carbon is what? 4. It's tetravalent. So for a compound which is optically active, it must have this kind of carbon, but it will bond four different groups. Example, just as we have in lactic acid. Lactic acid. I think that acid present in a rancid milk. Lactic acid. Look at the structure of a lactic acid. Look at the carbon here. Look at this one here. Look at this one here. Look at this one here. And now this one. I think, I believe, I'm correct. This is the structure of a lactic acid. This is the carbon here. It bonded four different groups. If you watch here, this is a carboxylic acid, this is hydrogen, this is a methyl group, and this is the OH group. So this is a kind of compound that is optically active, which is capable of rotating plain polarized light. Okay, let me make a repeat of that again because it will play a major role when we are diving into optical isomerism in detail. So, optical isomers always rotate plane polarized light because of molecular asymmetry. I have explained it, molecular asymmetry. Every compound that rotates plane polarized light is said to be optically active. And for a compound to be optically active, it must have a carbon atom surrounded by four different groups. For a compound to be optically active, that is, for a compound to be able to rotate plane polarized light, it must have a carbon compound surrounded by four different groups. Wait for the optical isomerism in detail in our subsequent videos.